Hello everybody. Today I want to continue my previous discussions about recent advances, advances in high voltage engineering during last decade. Today I want to speak about the differences between high voltage DC and high voltage AC systems. Um, in introduction, I will start with this fact that high voltage transmission comes into two main forms, as you know, AC and DC. High voltage AC has been the traditional backbone of the grids over the last 100 years. High voltage DC once niche has expanded rapidly in the last 10 years. Both technologies now play complementary roles in the renewable integration. In this talk, I will try to compare their differences, their advances, and their applications. About their basic differences, high voltage AC allows easy transformation of voltage via transformers. On the other hand, high voltage DC requires converters at both ends but lower losses over the long distances. This is very much important. HVAC dominates short to medium range transmission, while HVDC is best suited for the for very long distances and subsea applications. Adva Let's start with advances in HVAC or high voltage AC during the last decade. Installation systems have improved. Then we are have then failures in high voltage AC lines are reduced. New gas mixtures and solid insulation reduced the reliance on the SF6 gases. Facts devices like StateComs have enhanced the voltage stability. On the other hand, high temperature conductors allow higher capacity lines. It is very much important to mention that monitoring and diagnostic tools make the HVAC more reliable than before. About the advances in HVDC, I would like to tell you that modular multi-level converters or MMC revolutionized HVDC in the last decade. And now we know that 525 kV XLPE high voltage DC cables now transmit nowadays transmit power over 500 kilometers subsea. MTDC or multi-terminal DC grids have moved from the concept to the pilot projects. DC breakers and advanced protection schemes make the DC networks practical. And finally, HVDC has become the default choice for the offshore wind export systems. Applications of high voltage AC. As you know, high voltage AC remains dominant for the overhead transmission lines worldwide. It is cost effective for distances under 600 kilometers. High voltage AC is ideal for interconnected national grids. The most existing transformers, switchgears, and standards are HVAC based. They are based on HVAC. Recent upgrades focus on the reliability and environmental impact reduction. But about the applications of HVDC, this is, as you know, HVDC has many interesting applications, especially nowadays in the renewable systems. HVDC is widely used in subsea cables connecting offshore wind to, to the shore. It is essential for interconnecting asynchronous grids, for example, Europe to the North Africa links, or ultra-high voltage DC lines in China transmit the power over 3,000 kilometers. BESS and hybrid networks, hybrid renewable hubs often connect via HVDC for their stability. HVDC is now used for underground some urban cables to reduce the footprint. Comparative strengths. Here I want to compare their strength both HVAC and HVDC. HVAC is simpler and cheaper for the short distances. HVDC excels in long distances and high capacity transmission. HVAC allows easier integration into the existing grids. HVAC provides the better controllability and lower losses over long distances. Together, they form a hybrid transmission future. About the challenge for the AC, for high voltage AC systems, I would like to tell you that reactive power losses increase over the long distances. Large corridors are required for the overhead lines. On the other hand, aging infrastructures poses the growing reliability risks, and also SF6 switchgear still dominates. And though alternatives are emerging. HVAC upgrades, HVAC upgrades focus on digitalization and asset replacement. But about the challenge for HVDC, I would like to tell you that converter stations are expensive and complex. Protection of a DC grids remain technologically demanding. Multi-terminal HVDC networks need robust standards. Cable manufacturing and testing require the strict quality controls. Despite of these costs have declined significantly in the last decades. In conclusion, or I want to wrap up this discussion, in the last 10 years, both HVAC and HVDC have advanced significantly. HVAC continues to dominate existing networks with improved reliability. HVDC has expanded rapidly for offshore winds, long distances, and interconnections. The future will see a hybrid system. With both HVAC and HVDC, which they complement each other. Together, they form the foundation of a resilient and renewable ready transmission grid. Thank you.